Hello! In today's video we're going to be talking about the first section of Chapter 6 on an intro to trig functions, which is about angle measures. So the first thing we're going to do is address two very fundamental concepts, and that is that of a positive angle and a negative angle. A positive angle is going to start at what we call the initial side and end at the terminal side. So a positive angle will start at its initial side and rotate around counterclockwise to end at the terminal side. We can rotate this angle however many degrees or radians we want. We can rotate around as far as we want as long as we go in that counterclockwise direction. A negative angle will still start at its initial side, but it will rotate in the clockwise direction to end at the terminal side. An angle can be measured in either degrees or in radians. Now, radians is something that is going to be a little bit new. Radians are defined as the length of an arc formed by an angle of that many radians along a circle of radius 1. Now, let me show you exactly what I mean here. If we have a circle with a radius of 1, so here's my radius, and that distance is 1 unit. If I rotate around, let's say this is a positive angle, if I rotate around and end at my terminal side, this angle can be measured in either radians or degrees. Degrees is a more common measurement up until this point, but radians has a special relationship to the outside of the circle. Now, the distance that I traveled along the outside of the circle, I'm going to do this in very dark blue, is going to be equal to the number of radians that we traveled from the initial side to the terminal side. So maybe this is something like pi over 3 radians. Then that means that the distance from one end to the other that you might walk around this circle is going to be pi over 3 units. So radians can be translated directly into that arc length when our radius is 1. If our radius is something else, maybe our radius is 10, then in order to find that length that we would walk from one point to the next along the arc, we take those radians, pi over 3, and simply multiply by our radius. So in this case, I would be walking 10 pi over 3 units to get from one point to that next point along that arc that I've sectioned off in my circle. So radians have a very specific relationship to the circumference of our circle. Going from radians to degrees, 1 degree is going to be equal to pi over 180 radians. And radians are going to be equal to 180 over pi degrees. So I can now use this conversion factor to go back and forth between degrees and radians. If I know that 1 degree is equal to pi over 180 radians, I can use that relationship to convert 60 degrees into radians. So all I'm going to do is multiply the left and the right hand side of this equation by 60. 60 times 1 gives me 60 degrees. And then on the right hand side, I can reduce this fraction. My degree units reduce completely, giving me pi over 3 radians. So 60 degrees is equivalent to pi over 3 radians. To go from radians to degrees, I know that 1 radian is going to equal 180 over pi degrees. I have pi over 6 radians, so I'm going to multiply the left and the right hand side by pi over 6. On the left, I have pi over 6 radians, and on the right, my pi's reduce. 180 and 6 reduce into just 30, which means I'm left with 30 degrees. So pi over 6 radians is equivalent to 30 degrees. Go ahead and take a moment, pause the video, and practice converting these back and forth. If you're given radians, convert to degrees, and if you're given degrees, go ahead and convert to radians. Here I'll be multiplying by 180 over pi, and when I'm done, my pi's reduce, my 180 and my 3 reduce And 60 times 13 is going to give us 780, which means that we've got 780 degrees. 45 degrees is going to convert to pi over 4 radians. And the remaining 6, you can go ahead and check your answers now. A couple more things that we're going to be talking about are angles in standard position and coterminal angles. An angle in standard position, for the most part, it's going to be, generally all of the angles that we talk about are going to be in standard position when they're in a coordinate plane. And that means that the initial side is on the positive x-axis, and then the terminal side rotates around the origin. So if I have a positive angle, my terminal side might be in the second quadrant with the vertex at the origin, or maybe we have a negative angle. My vertex is still at the origin, and my terminal side would be rotated around clockwise. Now, coterminal angles are angles that have the same sides or coinciding sides. So in standard position, my first angle might be positive with a terminal side in the third quadrant. So that vertex is still at the origin and will always be at the origin if it is in standard position. Now, a second angle that is coterminal with this angle will have sides in the same place. So it will also be in standard position starting at the positive x-axis, but the angle does not have to be the same exact measure. It just needs to end in the same place. So maybe I rotate around a full circle and then continue to end in that same position. So my sides coincide with one another, but for my blue angle, that second angle, I did a full spin before I rotated to coincide with that same terminal side. So to find an angle that is coterminal, what we're going to do is we are essentially going to unspin our angles. In this angle here, I did an extra 360 degree rotation, or 2 pi, to get to that terminal side. My red angle did not have that extra 360 degrees, but my blue angle went 360, or it went 2 pi, and then it went around to end in that same position. So all I'm going to do is I'm going to take out those 360 degrees, or those 2 pi's, depending on if we're working in radians or degrees, to simplify down to an angle within the domain that we're looking at. So here my angle is 1,290 degrees, so I'm going to subtract all of those full 360 degree spins until I get something that's between 0 and 360. So subtracting 361, I get 930 degrees, so that's still outside of our domain of 0 to 360, so I go ahead and subtract 360 again, giving me 570 degrees. So I subtract 360 a third time, and I'm left with 210, which is within that 0 to 360 that we're looking at. So our angle is going to be 210 degrees. So what we did is we said there's this angle. This angle starts on that positive x-axis, and it rotates around 360 degrees. So I rotate this around. Then we do another full spin of 360 degrees. So I go another 360, and then a third rotation of 360 degrees, and then I go 210 degrees, so I am left with an angle that's approximately here. Instead, what we can do is, instead of spinning around 3 times, we can go ahead and start in standard position and simply rotate around to end at that 210 degree angle. These angles start and end in the same position. They are coterminal, but one is much more direct than the other. So go ahead and take a minute, pause the video, and try out 920 on your own. Subtracting 360, I'm going to be left with 560. Subtracting 360 again, I'm going to be left with 200 degrees, which is in the interval 0 to 360. So I am looking for that 200 degree angle. And the same thing will work with pi, with radians. When we're working in radians, 2 pi is equivalent to that 360 degree rotation. That just means you spun around in a full circle. So if I have 13 pi over 3, I want to subtract until I'm somewhere between 0 and 2 pi. If I divide 13 and 3, I see that this is going to be a little bit more than 4 pi. So that's beyond my interval. So I'm going to go ahead and subtract 2 pi. In order to have a common denominator, though, I need to multiply the numerator and denominator by 3. And I'm left with 13 pi over 3 minus 6 pi over 3, which gives me 7 pi over 3. When I divide 7 and 3, I do get something that's a little bit greater than 2 pi, so it's 2 point something pi, which means that I'm still beyond my interval. So I'm going to subtract another 2 pi. Since I need that common denominator, I multiply by 3's, 7 pi over 3 minus 6 pi over 3, and I'm left with 1 pi over 3. And this is going to be in the interval that I'm looking at, so my angle that's coterminal is going to be pi over 3. All right, go ahead and take a second, pause the video, and try out our next example. Here, since I've got a negative angle and I want to be in a positive interval, I'm actually going to add on 2 pi. That common denominator is 2, so negative 21 pi over 2 plus 4 pi over 2 is negative 17 pi over 2. So this is still negative, so I'm going to add on another 2 pi, or 4 pi over 2. Which gives me negative 13 pi over 2. Still negative, so I add on another 2 pi, or full rotation, negative 9 pi over 2, which is still negative, so I add on another 4 pi over 2, giving me negative 5 pi over 2, which is still negative. Adding another 2 pi, I get negative 1 pi over 2, which is still negative. So I'm going to do this one more time and hope that this ends up in the interval I'm looking for. Negative 1 pi plus 4 pi is 3 pi over 2, and this does simplify to about 1.5 pi, which is in the interval that I'm looking at. So my angle is going to be 3 pi over 2. And that brings us to the end of our first video for section 6.1. Thanks so much for watching. Have a great rest of your day.